Hello everybody, I will start my today another live coding session. In my today's video, I will solve this question, account merge. So I'm giving a list of account where each element account is a list of strings where the first element account I0 is a name and the rest of the element are emails representing the emails of the account. Now, we'd like to merge this account. Two accounts definitely belong to the same person if there is some common email to both accounts. Notice that even if two accounts have the same name, they may belong to different people as people could have the same name. Okay. A person can have any number of accounts initially, but all of the accounts definitely have the same name. After merging the account, returns the account in the following format. The first element of each account is the name, and the rest of the emails are emails in sorted order. The accounts themselves can be returned in any order. Okay. So let me clarify my understanding first. So in this question, as the interface, I will implement the method which whose input should be account, which is the to-do list. And for this to-do list, each list represent each account. And for the first one, first element should be the name, and the rest element represents the emails. And I will return again to the list of accounts. And one thing I have to take care is in each account, emails are sorted. Yep. So each element is the list. Yeah, and each list represents one account. So in that list, the first element should be the name, and the second or later element represents the emails. So these emails has to be sorted. Okay, so let me check some constraint. The first thing I'm wondering is if the given account has at least one element. I mean, one account or not. And I can find from the constraint that this is true. So there should be at least one element in the given to-do list. And in each, 2D, so in each list, which represents, each account, I'm wondering if there is at least one email. So I'd like to confirm this is true. And yes, this is true. So which means that each account has at least one email. Okay. And aside from that, yeah, I think I'd like to confirm there isn't any contradict. It doesn't say anything. Okay. Yeah. Oh, maybe one more thing I'd like to confirm is each email links and possible chart types. And I can find that this should be length 30 and chart types is only email. So only English letters. So I can say that there should be up to 53 characters, capitalize A to Z and capitalize A to Z and at mark. So there should be 53 characters. So maybe I can say each email I don't know how many. So I can say 53 to the 30 patterns of email. Definitely, I can say this is, constant. I just wanted to confirm the number of emails. Every possible email can be constant, but I couldn't say that. Okay. So let me take a look at some examples. So let's say I'm given something like this. This is name B, and I can say this should be like this. Yep. And let's say if this person actually aa.gmail.com. In that case, I can merge person A and C, but it can't be because they have the different emails. Sorry, different names. So definitely it should be like this. In this case, I can say there's the same account, and first A and third A as the same account because they share the same email, aa@gmail.com. But I can say, let's say, this and this. In this case, the third B and the fourth B, they're not the same person because they don't share any same account. Same email. So I can say these two B's are the same account. So I will return. Firstly, A and A should be merged together. And there should be C at email.com too, which should be sorted. Okay, this is it. Good. So, let me think of the brute force approach. So the brute force approach I can say is, I try to merge person in any brute force approach. So maybe I will create the hash map which says a@gmail.com. Mail address to person name. Maybe this should be the list. So I traverse each person, and for every email, I create this hash map, and this should be a kind of default list. So in this way, if this, there are, shared emails between two accounts, two people's names are put here. Or maybe I can say, it should be the account index like this. So maybe I put the number just like the index on this account. And for example, for where is it? aa@gmail.com, this should share this between person 0 and 1. I do it like this. In this way, I can say which account are merged together. So, yeah. At least I can say how I should merge the accounts. And yeah, that's it. So now I know which emails are, sorry, accounts are just merged together from this hash map. Yeah. But maybe there could be the possibility that it goes like this. In that case, I have to merge 0, 1 and 1, 2. So maybe I can use UnionFind here, or maybe more easy way to do that. Okay. And for each group, um, accumulate emails and sort them. Yeah. So this sorted list should be exactly the list which should be returned. I mean, each list in the 2D list to be returned. So I think this should work. Yep. Mm. Okay, so yeah, I think this is a kind of good idea. Mm. Or maybe if I don't use the UnionFind, I can just say I will create the I will think that this is a kind of edge between the groups, and after connecting all of them like this, maybe it looks like this. I do the DFS from firstly from account 0 and correct all the emails which belong to the same account as in 0, and this is one group. And because when I do the DFS, I visit 0 to 1, 1 to 2, 2 to 3. So these four accounts are in the same group. Excuse me. So, yep, now I find the group. So, or I can say union find or do DFS. Yep. Okay, so I think I'd like to go with this idea instead of using the UnionFind because the implementation should be much simpler, maybe. Or I should say, at least feasible here. I don't want to, stuck at debugging the UnionFind, so I will do this approach. Okay. So for this approach, let me quickly do the complex analysis. The firstly, I have to iterate all the account and average M emails. In this case, I have to traverse NM times and I can build the adjacency list. Yeah. Every time I append new element to this default list, I just have to create the kind of edge between maybe the first one to the last one, newly appended one, like 0x. then 0y, 0z. Yeah. So this is how I build CSS REST. So there should be nm times. Then I will do the DFS. So it totally no. So wait, do I have to do the DFS here? Yes, I have to do it. Because 0, 1 and 1, 2, 3 are connected. But actually it looks like this if I do this. As I said. So when I do DFS from here, I should visit exactly all the edges exactly once. Yeah. And also all the nodes exactly once. Maybe I will find some already connected, or I should say visited node. In that case, I have to skip. But in the worst case, I have to visit all the nodes. So it should be, wait, so nm edges in the worst case. Yeah. And number of nodes is nm. This should be the time compressor for DFS. And in the end, I have to sort them. In the worst case, all the emails belong to the same user. So it takes log nm times log nm. So in the worst case, it should be nm log nm. Okay. Good. Okay, that being said, let me start the implementation. So first thing I will do is build the JSS REST. But actually this JSS REST is not obviously complete one. Yeah, because when I do 0, 1, 1, 2, 1, 3, 0 and 3 are connected. But they're not adjacent, but it's okay. So what I try to do is building the JSS REST. In this way. So this is the adjacency REST. And the next thing I will do is do the DFS and connect all the emails together. So I should name it, or maybe I should implement the BFS inside here. Yeah, maybe I will do that here. Is there an account? So for each account, yeah. So I do DFS from here actually. So I do that. Okay, I will start implementing this. So again, I'm connecting account. Oh, so here, so what I will do is, so this is the past previous account, and I have the build adjacency REST. So this is the current account ID. And if it's already seen, I will continue. Otherwise, this is a new account. So I would append. Okay, so in this way, I expanded name to emails. Then what I will do is append this current and also register this to scene account. Yep. Now I've finished the DFS. So my expectation is that name to emails has all the, emails associated with the name. Wait, actually no. Name to emails, name can be duplicated. So I can do this. Actually, I think instead of name to emails, there should be account to emails. Maybe account index in the original given, account list. So yeah, so so what I've noticed is that so um okay, so here I was doing 0 is connected to 1 to 1 3, and so I've reversed it and I find that they're connected to this. So I think actually I just have to initiate this. When I come here, what I should do is I add this current I to this. And here, emails are stored here. So I actually don't have to make this default dict. Yeah. So now this. Okay, so what I can say is every time I find an account, all the emails in this account are pushed into here. Yep. Then I push the current account index into the stack. Okay. So let me make it a little bit more easy to understand here. So I is the original account index. Okay, and prevent current are the current or previous account index. Okay. Good. So now my sorry expectation is that account to index emails as the account. This should be the look like this. So what I have to do from here is convert this into the returned list. So this is the name, and I have to make email sorted. Then I append name list plus sorted emails list. Yeah. Oh, it's okay. It's okay with this. Then I return read. Good. Now let me implement the helper method. The adjacency list I'm expecting is something looks like this. So what I can do is this is the name, but actually I don't have to take care about the name here. All I'm interested in is account index and emails. So email to account indexes. This is account index and account, yes, and emails are account from index 1. So what I would do is wait. So I'm doing email to account index. But I no actually noticed something here. I don't have to build this default dict completely. So I actually have to do email to first account index. Yeah. And from the next duplicated email, I have to build a connection between first account index to current index. And also I have to take care that this should be bidirectional. Yeah. Or if not, I make the connection. Yep. So I connect first account index and current account index. And this and this. And return this in the end. Sorry, so I actually have a kind of code and I'd like to finish this video quickly. So terribly sorry, but I skipped the dry run. Let me run my code and check if it works. Okay, so I've got an error. It seems like this is a 3D array. Let me check it. So output is something like this. Mm. So this is the array, not array anymore, but included in this array. So it seems like this name is so already to the array. I think this is true. Count index 0 should be the name. Yeah. So now current problem is that they're duplicated emails. I see. So definitely this is a kind of trap. I had to know this by myself. So what I can do here is what do you mean? So account to index emails, sorted emails. I see. So here I have to do the kind of deduplication step. Sorted emails. Yep. email account to index emails. So this should be the set. And I have to make it add. Okay, the first problem is fixed. But now it has kind of weird situation. John has no email. And Mary has no email too. So let me check first if I return something correct. Yeah, so 0 to 1, 1 to 0. 0 to 1, 1 to 0, yes. These Mary and John should not be merged together. So this is as expected. Good. So first I can say this helper method is correct. And let me check this. So here, index 0 is pointing to this, and index 2 has no email. It's weird because index 2 at least have this email, obviously. So let me check. Ah, I see. So I had to, append the emails here. Yeah, because at this moment, I've already found the first person. So it should be the set of, no, not here. No, here. Okay. This should be like this. So when I start the DFS here, the emails belonging to the person I, from which I started the DFS, emails belonging to him should be obviously included to this set, email set. Okay. So now let me submit my code. Accepted. Great. So finally, I will do the space compressed analysis quickly. So the first data structure I built is in this method, and in this email to first account index, and also read. Let me restore of them, and adjacent list which should be returned, and seeing accounts, account index to emails, stack. And in the end, returned list. This is okay because this is something returned, but I need the here in line 90. I need the sorting extra space. Yeah. Okay. So for email to first account index, obviously this should be exactly, NM emails, NM keys. In the worst case, each emails included a different, so there should be NM keys, and value is exactly first account index, it should be nm. For adjacency list, in the worst case, I have to, connect all the nodes from the first index. So this should be exactly 2n, which is O of n. Yep. For account index to emails, this should be, so account index to emails. This should be in the worst case. There isn't any email merge. So in that case, the number of keys, this is exactly the same as almost same as the given account data structure. So there are n keys and each value has m emails. So it should be nm. For seeing accounts, this is exactly the number of accounts. This should be n. For stuck, again, this should be up to O of n, because I'm doing DFS and each element is each account. And there n account. For sorting, I'm doing this for nm emails. And in Python temp sort, it takes the linear space, extra space complexity. It should be O of n m. In total, this should be O of n m. Okay, good. Let me quickly wrap up. So today, I said the question, account merge. So I'm given the list of account, and each account, which is a list, represent name and belonging emails. And my task is to do account merge. So if two accounts share the same email, I can merge these two accounts. Yeah. So basically what I did is firstly I built the adjacency list, which and each edge in this adjacency list is merge account IDs. And from this adjacency list, I did the DFS. Yeah. And so I did DFS. And what is it? Yeah. I built account index to emails. This is actually first account index to emails. I did this because there could be duplicated names for different accounts. And in the end, I converted this first account index to the name and created the 2D list. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.